Assalamu alaikum guys, welcome back. Okay, so this is lecture 2. Now we are going to study the trends of the ionization energy in the periodic table. Okay guys, so now this is your periodic table over here, and in this periodic table, if we go up the group or if we go across the period, ionization energy will increase. Okay, ionization energy will increase in both the cases. Okay, going up the group and across the period. So up the group and across the period increases ionization energy. So if I were to ask you what will happen to the ionization energy if we go diagonally, then the answer will still be the same. It will increase. Why will it increase? Because going diagonally means going up the group and across the period. Okay, so in this case, well, in these trends, the noble gases, they are excluded. Okay, because they are an exception, they have a slightly different trend, and so are the radioactive elements over here excluded. This francium in group 1 is also excluded because it's radioactive. Okay, it's radioactive. Now so according to this trend, fluorine will be the most electronegative element of the periodic table, excluding the noble gases and the radioactive elements. Okay, the most it will be the fluorine will be the, I haven't discussed electronegativity yet, but fluorine is going to be the element having the most ionization energy right now. Alright, then apart from these trends, what happens to the atomic radius as you go across the period and up the group? We have to discuss this trend as well. Atomic radius, what do you guys think will happen to the atomic radius as we go up the group? Well, atomic radius, if you look at the size of the atom, atomic radius basically means the size of an atom. Okay, so if you've got a hydrogen atom over here, what's the radius of a hydrogen atom? But do you know one thing? The radius isn't measured. You cannot measure the radius of an atom. So what you'll need to do to measure the radius of an atom is simple. You'll take a whole molecule of that atom. Okay, what scientists have done, okay, this is a whole molecule of hydrogen, and they take the distance in between their nuclei, this bond length, basically the bond length is taken, and half of that distance is the radius. Okay, half of that distance is considered the radius of that atom. Now if you look at the radii and going down the group, what happens going down the group? The number of shells, what happens to the number of shells, the number of electron shells? They are increasing, right? Because lithium will have two shells, sodium will have 3 shells, potassium will have a shell more, rubidium will have even more. So as you go down the group, the size of the atoms is increasing, right? The size is increasing. So if the size is increasing, that actually means that going down the group, the radius will have to increase, right? So going up the group, the radius has to decrease. Okay, it won't increase, it will rather fall, it will decrease. Okay, and going across the period, what happens to the radius? Well, going across the period, the electrons are still increasing. But guys, remember one thing, going across the period, the radius is expected to increase, right? But no, the radius actually falls as you go across the period. The reason for that is because the shielding effect is constant. Okay, the total number of shells is constant. Okay, what do we mean by shielding effect? Do you guys know what shielding effect means? Shielding effect. Alright, shielding effect. Let me just quickly explain what that is. You guys, I'm expecting you might know what that actually is. Okay, if you go, for example, this is an atom, the nucleus of an atom. Okay, this is the first shell, this is the second shell, this is the third shell. And now, for example, there is an electron over here in the third shell. The third shell, assume it to be the outermost shell. And now there are certain electrons over here, and in between the nucleus and that electron, the outermost electron, the inner electrons are also negatively charged, the outer electron is also negatively charged. If both of them are negatively charged, what do you guys think? Will the inner electrons, will they attract the outermost electron, or will they repel it? They'll repel it because it's negative. The inner electrons are negative, outer electron is also negative, and if that is also negative, that actually means there is a repulsive force by these inner shell electrons. This repulsive force is actually the shielding effect. Why is it called shielding effect? Because this nucleus inside is positive, right? It's positively charged, and this nucleus, what it will tend to do is it will tend to attract the outermost electron towards itself, right? It will try to attract that electron towards itself due to its positive nature, and that electron being negative, right? But what these electrons, the inner electrons do, they shield this outer electron from this attractive force of the nucleus by providing their opposing force. Okay, this opposing force provided by the inertial electrons is called the shielding effect. So now if you look at the periods, for instance, these periods over here, as you go across the period, you might be knowing that the shell number remains constant. Okay, the shells are constant across the period. They are constant as you go across the period. If the shells are constant, then that actually means the shielding effect will also remain constant. And if the shielding effect is constant, then that actually means the inertial electrons are not changing. And if the inertial electrons are not changing and going across the period, what going across the period actually does? It increases the proton number, right? Proton number can also be thought of as the nuclear charge, because the nucleus has the charge of the protons, right? Nuclear charge. So as you go across the period, the nuclear charge increases, shielding effect remains constant, so the overall electron density around the nucleus, it shrinks towards the nucleus, because the shielding is not increasing, but the nuclear strength in the middle, it is continuously increasing. So the nucleus will try to pull the outer electron towards itself while keeping the electron density between the nucleus and the outer electron constant. Alright, so that's why going across the period, the radius has to shrink. And what about the shielding effect? If we've discussed what shielding effect is, let's put in the trend of shielding effect as well. What happens to the shielding effect as you go down the group? Well, it's not very important to discuss the shielding effect in the groups, because as you go down the group, the shielding effect, it obviously has to increase as you go down the group, right? But so is the proton number increasing, so they kind of balance out each other. So there's no significant effect of shielding or significant role of shielding effect over here in the vertical group, but there is a significant effect of shielding effect across the period. We know that shielding effect is gonna stay constant across the period, okay, due to the constant number of shells, and due to that the radius is decreasing. Okay, so that's what we have to put. So this was a quick overview. Now guys, remember one thing, ionization energy, it changes across the group, okay, as shown over here. And why does it change across the group? I'll explain that in the next lecture. It changes across the period. Across the period it is changing, right? Ionization energy is increasing. Going up the group, it is changing. As you go up the group, it has to increase. As you go across the period, it has to increase. And as you go diagonally, it still has to increase. Successive ionization energy means first ionization energy, second ionization energy, third ionization energy, fourth ionization energy, and so on for the same element. So we have to discuss the trends in those as well. Of the successive energies, well, not very in a lot of detail, but slightly. Okay, and that's it for this lecture. We'll continue with the group trends, the explanation for why ionization energy changes in groups in the next lecture. Thank you.